Hello, everybody, and welcome to episode 5 of I Wish You Were Dead, a podcast about things that used to be alive. My name is Mike. That is Gavin. Gavin, how does it feel that we have now been podcasting in 2 years?
It feels incredible, Mike. We have officially been a podcast for 2 years. It's technically official, even though it's realistically been 5 weeks. But that's the details. Details.
Look, I will gladly take whatever we can get out of this. I am so glad. We are, just to, once again, as the beginning of our podcast is want to do, pulling back or looking into that fourth wall. We're recording this in 2020, but we are happily talking about what it's like to be in 2021. And I think that I can speak for just about anybody listening. I am glad to be out of 2020 and into this vast new world that is 2021 with all the promises and hopes that it has for us.
Thank God.
Thank God indeed. So I think we can get right into this very quickly at the beginning. We are not going to be doing our part 2 of Gavin's field work in this episode. We have that planned for the future. I'm definitely looking forward to getting a little bit more in depth on that field work that Gavin is doing. But in this episode, we're going to be doing it's sort of a couple of different things. We've got like a main lesson and a way we're going to do that main lesson. And apparently also, as I'm looking at our bullet points that Gavin has written for us in this episode, we're mostly going to be making fun of me and
Yes.
how much I don't know. So Gavin, can you just explain to everybody what it is that this episode is actually going to be about and why I'm already wrong about things?
Absolutely. So I want to put out a content warning here in that this will be one of the more technical episodes, like scientifically technical episodes that we will record. So I just want to put that out there. Try and stay with me. We will have some links, just as we did for last episode, for you to sort of follow along if you so choose. But I'll try to make it as layperson comfortable as possible.
Which is also my job, is just to make sure that the average Joe that doesn't actually know what they're talking about can understand what's going on. That is most of my role here, and I will do the best I can in what is going to be one of our most technical episodes.
Yeah. So as we sort of talked about probably a couple times, but I think we talked about it a lot in episode 1. But a lot of science, especially once you get to graduate school, is unlearning things that you learned at lower levels. So, for example, and this doesn't just apply to like graduate school or college, but when you're like, I don't know, a sophomore or so in high school, you start on, or whenever you take, high school biology where you live. For me, it was ninth grade, I think. But you sort of unlearn some of the things, or get a little more clarification on some things that you were taught in like elementary school, where it's like what you were told was like sort of right, but not right because of this thing that was too complicated for an elementary schooler to understand. And that just sort of shifts as you go up through science. So like in graduate school, I'm unlearning things that I learned in like the early couple years of undergrad. So this is sort of going to be me talking about vertebrates specifically, because that is the group of animals that I work with, and sort of some of the unlearning that I had to do will be passed on to you.
So this is going to be very similar. I've mentioned a couple of times how I'm a social studies teacher. This is going to be kind of similar to how I have to teach some of my seventh graders that it was not Christopher Columbus, Jesus the Pilgrims, and George Washington that threw the tea overboard and wrote the Declaration of Independence and started America. It's a little bit more complicated than what they might be remembering from second and third grade. Not to say that it is necessarily wrong. They might have kind of the right general direction, but it is oversimplified to a point of almost being useless in any technical sense. And so that's going to be kind of, I think, the exercise that we are going for here is maybe taking what you might remember or the gist of what you might remember and distilling that down into what is actually correct for the kind of science that we're trying to do here.
Yeah, definitely. So, well, I guess we'll start right off and talk about vertebrates. So, I know they're in the Google Doc. So, Mike, look away from the Google Doc for a second, and
Understood.
listeners, you can play along as well. A little bit of a game. So, I'll give you this: that there are 5 sort of quote unquote main groups of vertebrates. So, Mike, off the top of your head, what do you think those 5 groups are?
5 main groups of vertebrates. So mammals, I
Yeah.
assume, have to be one. I'm gonna say so we've got mammals, probably like reptiles,
Yep.
amphibians,
Yep.
fish,
Yep.
and
You're
so
miss.
mammals. I'm
Yeah.
missing an important. Is it? Let me ask you this question: Is it an obvious one?
Yes. You see them every day.
Oh my gosh.
In fact, on land, they are by far the most diverse, most common group.
Gavin, you're not really helping me here. In fact, you're really shooting my self confidence. All right, hit me here. I'm apparently I'm missing one that apparently all of our listeners should have already gotten by now.
Birds.
Oh goodness.
So you'd be forgiven because I think we
Oh
did talk
my
about. I
gosh.
think you'd be. We did talk about how birds are technically reptiles, which we'll get into later in this episode. So you'll be forgiven if you were like, "Oh, I already said them because I said reptiles." Ha ha ha.
Yes, that's the technicality that I'm going for. Is that I said reptiles and also meant birds. That's exactly what I had in my head.
Exactly. See, but so most people think, when you say fish or amphibian or reptiles, most people know what you talked about, and for the most part, that's true. However, what most people think that just because most people think it, that doesn't mean that it's actually true. So with a lot of extant or currently alive animals, not extinct animals, it is pretty cut and dry. They fit neatly into these groups because we made these groups based on the animals that are around, you know, and then we fit extinct animals into them, or if they don't fit neatly into any new one or any currently made group, we make a new group for them. However, a lot of these groups are way more complicated than you might think. So let's just start at the most quote unquote simple of them, which is fish. So, fish, and we're just going to be going down. So, I'll give you a little fourth wall stuff here. In our notes, it says, "Ask Mike, what is a fish?" And then in the next bullet, it says, "Explain why he's wrong." And then in parentheses, "No offense."
Which I assure you, no offense is taken for any of this.
So, Mike, what does a fish mean to you?
So as I'm trying to think about this, what is a fish? My first thought when it comes to a fish is something that is number one, lives exclusively or functionally exclusively in the water and breathes through gills and isn't particularly big. But as I'm trying to work through this and trying to see where this is going, immediately what comes to my mind is things like dolphins or whales or sharks. And do those count as fish? And does the size make a difference? And this or that. So I'm going to try and put my definition of fish at something that lives exclusively or basically exclusively underwater. That, you know what? I'm actually going to leave that definition there. I'm going to try and keep it as broad as possible
Okay.
for this because I think that that's going to encompass the most number of things instead of it just being um, instead of it being more specific, just anything that lives basically exclusively in the water is going to count as a fish for our purposes. How'd I do?
It's okay.
It's okay, little Johnny. Yes.
You did your best. So fish are. So I'll come right out and say there is no group. Every other of those 5 main groups, there is a group of animals, like a scientific group of animals of that. So, for example, amphibians is the class Amphibia, reptiles is Reptilia, birds is Aves, mammals are Mammalia. But there is no group for fish because fish are so weird and crazy and diverse. Like fish are by far the most diverse vertebrates like on the planet by a large margin. And so there's no single group of fish. There are, however, some big groups that encompass what most people think of when they mean fish. When most people think of fish, they usually think of a member of the group Osteichthyes, which are the bony fish. These are the fish, basically anything that you can think of that is a fish besides something that is a shark is a osteichthyon, or a bony fish. So that is what most people mean when they say fish.
Can you repeat that one more time just so I can try and pronounce it for my next question?
Sure. Osteichthyes.
Osteoiches. And so, what are the defining characteristics of an osteoiches, and what would separate it from, say, a shark?
So the biggest thing is that they have bones. So sharks do not have bones with the exception of their jaws. All of the other group that sharks are in is called chondrichthyes, which are technically, like, the technical term is the cartilaginous fish because they are made of cartilage. So that is the main difference between those two, is that bony fish have real, actual, like, hard bone, and chondrichthyans have soft bone cartilage. That is the biggest difference between the two. There are a lot of other differences too. So for example, if you've ever, if you happen to be like a fisher and have, gutted a couple of fish, you probably know that most osteichthyans have a what's called a swim bladder, which is basically just this bladder of that they fill with air to sort of control their buoyancy in the water. Sharks don't do that. They do a really complicated thing by creating oil in their liver that is less dense than water, that makes them less dense than water, so they can create that and break that down very, very quickly to make themselves more dense or less dense, depending on where they need to be in the water.
Correct me if I'm wrong here, but just as I'm thinking about this, the difference between the fish that most people would think of and sharks, wouldn't another rather key difference be their size, or am I kind of off base on that?
Not necessarily. So the largest fish around today typically are sharks. Yes, they are typically things like whale shark is the largest. Um, I think it is the largest, like, non-whale animal alive today. Because despite it being called a whale shark, it is a true shark, unlike whales, which I'm sure we will talk about in a bit. But yeah, they are the largest fish alive today. That doesn't necessarily mean that chondrichthyans are bigger, because there have been, bony fish. One that comes to example is one called Leeds ichthyes that was alive. I don't know exactly when this thing lived. I just know that it was really, really big, pushing 60, 70 feet. So very, very large. And it was a bony fish. So that's today, yeah, that's probably true. Although there are some really big osteichthyans around today. Things like the sturgeon can be 20 plus foot. Things like, bluefin tuna can also be very, very large. So in general, yeah, but I wouldn't use that reliably.
Understood. So that's something of a both recency and unfamiliarity bias on my part when it comes to size.
Yep.
So we've talked a little bit about kind of what fits into that fish category. Do we have any kind of a reliable definition for what is a fish? If you were going to put a definition on that, I did my best.
Yeah.
And you gave me the old D student who just gave an answer that was almost correct. How would we define a fish scientifically?
So this brings me into probably the first really technical thing that I wanted to talk about today, which are different types of groupings when we're making sort of like a tree of life. So the main one that we focus on is, say you pick a species. So say you're imagining a tree of life diagram in your mind. You pick one of the branching points, one of the like the base of the V, basically, that it makes. You pick that and everything above it, so all of its descendants. That is called a monophyletic group. Those are the good ones that we want. The bad ones are something. So say you take that same spot and then include all of its descendants, except for maybe a couple. So say you exclude some of the branches at one end because they don't quite fit.
That was going to be kind of one of my questions. Is it possible that you start kind of too far back on this tree of life, and everything that comes beneath eventually becomes so disparate that it doesn't make any sense to include them in any one species or genus.
Absolutely. And so that kind of group is called a paraphyletic group, and fish, quote unquote, is probably the best example of this, because technically, if you wanted to use fish as a monophyletic group, you would need to include all the other types of vertebrates: mammals, amphibians, reptiles, birds. Technically, if you want to make or even an Osteoicis monophyletic group, because all of those other groups are descended from fish, technically they are members of Osteoichthyes. So, Mike, technically you and I are bony fish by this definition.
I'm putting that on my resume.
As you should. It's very impressive. We're just incredibly derived fish. So that is one that we tend to stick away from.
You know what? Screw my resume. I'm putting derived from fish on my Tinder profile at some point.
Like
Once
that.
my girlfriend breaks up with me, I'm putting that on my Tinder profile.
Oh my god. Okay, if that's, I mean, it'll turn some heads, that's for sure. Yeah, so that's the trouble with trying to make monophyletic groups with some really, really large groups, where things like you or I have almost none of the characteristics of an Osteoichthyes, but because our ancestors were, we technically are them too. Is that really useful to say? Not really. And it's also, they can be useful to use paraphyletic groups, because when people refer to Osteoichthyes, you're not referring to a mammal. You're referring to a fish that most people think of. Another good example is whales, because whales technically descended from the same group that things like cows, deer, and hippos are a part of, which is called the Artiodactyla. It's the hooved animals that have either 2 or 4 toes. Whales are technically members of that group because they descended from a member of that group that was somewhat closely related to hippos. So technically, whales are hooved ungulates, which is just, ungulate is a word for things that have hooves and run. But technically, whales are a member of that group, but they're so far derived and have none of the features of them anymore that it's not useful to talk about them in that sense.
So it sounds as though you're telling me, as we're trying to get into this, or maybe you're going to try to get into this, that any definition that we try and come up with scientifically for fish is going to wind up including a lot of things that just don't fit into that category. And it winds up becoming a category that is so broad as to become useless.
Pretty much, yes. Which is why they try to refine it a little bit more. But there's one more group that I want to discuss before I want to get a little further into that. And that is what's called a polyphyletic group, which is the absolute worst kind, because it's not based on being related at all. It's just based on features. So have you ever heard the term pachyderm?
Pachyderm? I can't say I have.
So it is a term that is generally, because it means, like, it literally translates to thick skin. And it's a group, mostly made up of like African animals like hippos, rhinos, elephants, because they have like this thick leathery skin. And that was, they were put in a group called Pachydermata because they have thick skin. And that was a real scientific group for a little while, because we hadn't yet decided on grouping animals based on ancestry, and we're only doing it by traits. So that is called a polyphyletic group, because it's a group made up of animals that are not closely related and exclude ones that are closely related to those animals that you are including. So, like, it's a polyphyletic group because you are taking multiple different things and turning them into one thing.
So this is kind of something where you would have, for instance, people probably further in the back that maybe did not quite understand evolution the way we do, that we're just trying to put things into a category, and would say, well, we've got these animals that all have this trait in common, and that trait is more of just a coincidence of evolution, or I believe is the term convergent evolution, as opposed to it being actually related when it comes to the tree of life. Is that the right way to think about this third term here?
Yeah, that is a pretty good way to think about it. It's not quite convergent evolution, but it's as much about convergent evolution that a layperson really needs to understand is that sometimes different, distantly related groups can evolve traits that are the same just because they work well in whatever environment they're in. For example, let's see birds and bats both flying. That is convergent, because their common ancestor way back in probably like the Carboniferous period or the Permian period, probably like early Carboniferous, so like 300-ish million years ago or so, did not fly. So because each of those evolved to fly separately, that is a convergent trait, which may be, under the old system used to link, say that bats and birds are pretty closely related when, like I said, they're separated by like 300 million years.
So, and what we're talking about here would just be the same as like if somebody from South America and somebody from Asia all happen to wind up with brown hair and trying to put us all in the same, family. The fact that we all have brown hair doesn't actually really mean a whole lot when it comes to what it is we're actually talking about here. It just so happens that we all wound up having brown hair through the process of evolution and natural selection.
Yeah, that's a really good comparison.
Wonderful.
So I don't want to spend a ton more time on fish because fish are a super weird, diverse group. But there's also members that most people don't think about besides the two groups that I mentioned, the bony fish and like sharks and rays are in that group too, like stingrays are in chondrichthyes.
R.I.P. Steve Irwin.
Oh, the man, the legend.
Can we do an episode on Steve Irwin?
I can try.
I would love that so much. I miss that man. There was very few things I remember in my life from before I was, 8 or 9 years old. I forget exactly how old I was when he died. But Steve Irwin is one of them.
Yeah, we can try. But so there's those two main groups, and then there are what's called the jawless fishes, which are more primitive because one of the biggest, I'd say arguably the biggest, revolution in vertebrate history is growing a jaw, because there are vertebrates such as things like you might have heard of like lampreys or hagfish that they have a mouth, but they do not have like a bony jaw with like good musculature and true teeth in it. Instead, they're basically like little horns made of keratin, the same material that like cow horns are made out of, and they use those to just sort of bite and rip off things. So like they have musculature, but they don't have any bone in their jaw. And those would be quote unquote fish as well. But they are a separate group that sort of Osteoichthyans and Chondrichthyans evolved from. And they just have a couple members that are left. The rest of the group is kind of no longer around. But so moving on sort of up through fish, Osteoichthyans are the group that I'm most familiar with just because that's the group that turned into vertebrates. So there are two big turned into tetrapods, which I'll explain what that is in a minute, but it means 4 feet is what tetrapod means. So it's things with like 4 limbs, basically every vertebrate besides fish. But there's 2 big groups of Osteoichthyans. There are the ray-finned fish, which is pretty much every fish that you can think of, whether it's, perch, bass, whatever, anything that is not a shark, that is a bony fish. If you're thinking of it, it is probably a ray-finned fish. The other group are the lobe-finned fishes, which actually have some bones in their fins, whereas the ray-finned fishes don't. They have some weird kind of struts made out of keratin as well, and they're not that closely related to tetrapods, but the lobe-finned fishes are called sarcopterygian fishes. Their bones and their fins are what turned into our arms and legs. So members of this group are things like lungfish, or things like coelacanths are a very well-known member of this group. So they turned into amphibians. So Mike, what is an amphibian to you?
Before we do that, can I actually ask you one quick question that kind of goes back to level 0 for what it is we're talking about?
Absolutely, yeah.
So you've mentioned a couple of times about vertebrates and everything.
Hmm.
I think I know what a vertebrate is, but
Okay.
because we are kind of blasting definitions on this episode, I just want to make sure that we all have a common definition of a vertebrate. So if you wouldn't mind, just for both myself, because I think I know what a vertebrate is, and for everybody else, what is a vertebrate really?
So the technical definition are things with bilateral symmetry. So if you cut it down the middle, starting from like the top of the head down, it will be symmetrical on both sides. It has paired muscles going down the front. So there's, the same muscles on both sides as well. That kind of goes along with being symmetrical like that. But most importantly, it's got a dorsal nerve cord, which is exactly what it sounds like. It's a cord of nerves that goes down your back, and a notochord, which is this like really stiff rod of cartilage that also goes down your back to give your body structure. Those are the main things that a vertebrate needs, but for most in as far as most people are concerned, it is animals with bones. So again, that sort of loosely only applies to things like sharks and those jawless fish because they have cartilage instead of true bone. So that's a loose definition, but they're things with a backbone. Things where if you were to look at a skeleton, it would be on the inside, whereas opposed to something like an arthropod, which are things like insects, spiders, scorpions, crabs. They have an exoskeleton, so a hard, stiff skeleton on the outside.
I'm glad we went through that because the definition I had in my head was just animals that have a backbone, and I'm glad that that's like basically correct, but there's kind
Yep.
of more to it. I'm glad there's more to kind of see there. So going back to kind of the next thing where we ask Mike to define something and then explain exactly where I'm wrong. We were talking about amphibians, correct?
Yep.
Wonderful. So amphibians. When I hear amphibian, the first animal that comes to my mind is a frog, and then after that they are like those car boats that like you take tours on in Boston, and they're like you're going around the city and all of a sudden you're in the water and it becomes a boat. And so when I hear amphibian, the basically the only thing I can think of is, if I were to try and define it, is something that spends, a minimum amount of time in the water and a minimum amount of time on the land. Something that really kind of needs both to survive. It could not survive in the middle of the ocean or a freshwater lake, but it also couldn't survive in the middle of any kind of land. Something that needs to spend a decent amount of time in both places. That's what I think of when I hear amphibian or an amphibious creature.
Okay. That is largely true. So they obviously there are exceptions to all of those things. So there are some purely aquatic amphibians. One that comes to mind are things like the axolotl, which are a type of salamander who probably the most commonly kept pet salamander because they have like the external gills that you see if you look up. It's anyone who feels the need to look it up. It's AXOLTL, I believe it's how it's spelled, but I'm a little dyslexic, so it's probably not right. But anyway, uh, so there are some exceptions, but that's broadly true. The main thing that's sort of descriptive of amphibians is that no matter where they spend most of their time, things like toads spend almost all of their time on land away from water, but all of them need water to reproduce because their eggs do not have a shell. They just lay their eggs in the water, and if they were to lay them on land, they would dry out and die. That is sort of the key thing with what most people consider amphibians.
Is they need water in order to be able to reproduce, more so than they need water to be able to survive. It's more that they need water in order to be able to reproduce, and any time that they spend in water is almost coincidental to that reproduction.
Yes and no. Like, obviously, there are some that spend the majority of their time in the water, like axolotls. So I want to lead with by far the largest group of amphibians that are around today are frogs. Like 90% of amphibians around today are frogs. There's one group that's really weird called Caecilians. I won't know almost anything about them. There's not that many of them around. The other group, namely, is salamanders. But so there are salamanders who spend most, if not all, of their time in water. Frogs are more variable in that things like toads have thicker skin that they can't really breathe through anymore. That is another big thing of amphibians, is that they, if they are in water and their skin is wet, or even if they're on land, if their skin is wet, they can exchange gases through it, not as efficiently as through their lungs, but they can still do it. But toads can't, because they made their their skin a little thicker in order to sort of protect themselves. Plus, they have some cool like poison glands on them. But the main thing is the thicker skin, so they don't dry out. So they can be. There are some like desert toads that reproduce like the one time it rains in the desert.
A desert toad?
Yeah, so there's an actual very cute species of frog called the desert rain frog. It's definitely worth your time to look it up.
We are going to put a link in the show notes for this, because Desert Rain Frog sounds like the name of the band I'm going to start with a couple of friends that have recently quit doing drugs, but still
Oh
like
my
are cool
God.
to be around.
But yeah, so that is the single big thing with amphibians, is that they never evolved a true way to leave the water. In that sense, they are a lot like fish, because there are a lot of species of fish that can survive for like a couple days at a time on land. However, no matter how well adapted to land you are, things like toads, perfectly well adapted to land, if you cannot reproduce away from water, you will always be at kind of a disadvantage, because water is one of the first things to go when there's like a change in climate, which not just happening today, but happening throughout all of Earth's history. Water is really temporary, with the exception of the ocean. And so you're always at kind of a disadvantage with that.
This kind of reminds me of, I believe it was our second episode, when we were first talking about dinosaurs. We were talking about Pangea, and we were sort of talking about how when it came to the center of Pangea, there just wasn't enough water for a whole lot of anything to survive. And that goes for nearly all life that, or really all life that we know of today. But it kind of, if we're kind of taking that concept and expanding it out for amphibians here, amphibians that can survive on land, that, as you say, toads are perfectly well adapted to survive on land. Well, that's great. We can take one toad and we can take it wherever we like on land for any particular length of time. But at the end of the day, if we want there to be more toads, if we want these amphibians to be able to continue to survive, there needs to be a rather reliable water source around them. Otherwise, they really won't be able to get all that far from that water source without dying out.
Exactly. So what the one big thing with amphibians, besides them needing water to reproduce, is something that I hadn't really thought about until just like last semester, is that even though they are technically members of the same group of the first things to ever, crawl onto land, they are technically in the same group. They are nothing like what those animals would have been. So living amphibians are not at all a good analog to the first things to come on land. So you can't really compare things like frogs to something like one of the earliest tetrapods. Like I said, those things, technically, we are tetrapods because we have 4 limbs that we use to move around. The first tetrapods, the earliest one that comes to mind is something called Tiktaalik, which, very cool thing that it's just barely got things that you could probably call limbs. So that's like on the fence of whether it's a tetrapod or still just a fish. A frog is nothing comparable to the first things to crawl out of the ocean.
And why specifically is that? So they're like, what is that difference?
The biggest thing is, you know, 350 million years of evolution. You know, so yeah, they're still tied to the water, but that doesn't mean they just stopped evolving. It's not like they crawled out and were like, I'm good here. That's not how evolution works. You might hear of like the phrase like a living fossil. That phrase really shouldn't exist, because that implies that things stop evolving because they're like good enough for their like environment. A really good example of something that's commonly called that is the coelacanth that I mentioned earlier. We thought that coelacanths were extinct for like 60 plus million years until somebody fished one up in 1938. And it looks very much like the last one that we had, from the fossil record. But that doesn't mean that this one, or this population that's still around today, isn't evolving. It just means that, maybe the changes that are happening are not fossilizable. Things like they're becoming more efficient at eating. Maybe they're eating different things. Maybe they have a slightly different feeding mechanism. Maybe they have a different reproduction mechanism that we don't know about. So just because they are still tied to the water and are still quote unquote primitive, that doesn't mean that they are comparable to the other primitive things.
This sort of reminds me of what you were talking about earlier when it comes to kind of classification errors, where just because these particular organisms happen to share a particular trait doesn't really mean they're all related. It means they happen to share that particular trait, which is something to take note of, but not necessarily something to classify organisms by.
Exactly. So the technically correct term for amphibians today. So this is something that you might be thinking of if you're vaguely familiar with sort of like the kingdom, phylum, class, order, family, genus, species system, is that once you get into higher levels of biology, you realize that's all nonsense. We don't really use that anymore. Besides, like genus, family, genus, and species are pretty okay. But
Are you
anything,
joking?
no, we don't use that. So because, for example,
God.
so I'll talk about this more when we get to birds. So keep that in mind. But amphibia is a class. It is on the same level as reptiles, mammals, birds. But technically, reptiles evolved from this group. It is a subgroup of amphibians. But yet they're the same rank. So the whole rank system kind of doesn't make sense. Do you see what I mean?
Uh, on some level, I can see kind of how that works. If something evolves from something else and yet it is on the same rank, clearly there is some sort of a problem there. But isn't there still isn't that how species are named, like by genus and then species? And doesn't that still go with that? Like I'm still when you say that you guys don't use the kingdom, phylum, order, class, etc., like is it not used at all? Have I been taught it wrong? Is it kind of one of those areas of science that is undergoing some changes? How does that actually work?
We still use the names. So, like, well, amphibia is a bad example for that because nowadays most people use lis amphibia because that includes a lot of the maybe not the absolute first things that crawled out of the water, but the things that directly came from them. And what we would think of as amphibians today, it includes all of those. Whereas amphibia, as most people think about it today, only includes the ones that are alive today. And their most recent common ancestor. So there were lots and lots of different groups of amphibians that just didn't make it to today. We only have like one lineage that happened to make it to today. That is frogs, frogs, salamanders, and those weird Sicilian things that I mentioned earlier. But taxonomy is really weird in that it's always changing. And like I said, we still use a lot of the terminology, a lot of the names, because that's just what most people know, including scientists. If you were to just say, oh, everything that is an amphibian, I'm calling supercalifragilisticexpialidocious. I'm calling it that now. Everyone would be like, what are you doing? We already have a name for that. If you want to change the definition of what that name means, okay, we might be able to work with that. But calling it something completely new when we already have kind of a name for it isn't something that really happens.
Okay, so there's kind of no reason to reinvent the wheel when there's already a name for something, even if the very strict hierarchy that I was taught in Mr. Machiavelli's 7th grade science class and Miss Lincoln Hoker's 10th grade biology class, that might be, as we kind of talked about at the beginning here, a little too simplistic for the way science is actually done. Not to say that it's not used, but it's not quite as rigid as I was led to believe.
Exactly. It is, and especially like in sort of the middle few ranks, it is very flexible. And that is why we've come up with a new word, and new as in, we've been using it as long as I can remember. I don't know exactly when it sort of became a thing to use it, but remember those monophyletic groups that I was talking about, where you sort of pick something and all of its descendants, no matter how different they are in this group?
Yes, that was where we were talking about like the V at any branch of the
Yes.
tree of life.
So a new word that I'm going to introduce here is called a clade, which is just a monophyletic group. And essentially, you can just pick any V and go up from there, and there is a name for that group that you just made. So, for example, tetrapods that I was just talking about is a clade called Tetrapoda. It does not fit neatly anywhere in the kingdom, phylum, class, order, family, genus, species. It doesn't fit neatly anywhere there. So it is a clade. It is in between a couple of them, but it doesn't fit nicely. And there's even lots of other, extensions. You can have subclasses, infraorders, suborders, all sorts of different things. But even with all those prefixes that you add to make it more specific, there's just not enough flexibility to encompass how diverse life really is. So that's why we have clades.
And I love that we have kind of this rigid order that we were taught at in the science class growing up. At least I certainly was. And then, while that is instructive to actual scientists such as yourself, it is not the only thing that is there to worry about. It is not kind of the only thing to focus on, because real science is a little bit messier than we were all probably led to believe in school.
Absolutely. And actually, I'm I just reminded myself of something that I actually got a little wrong. So I actually had that backwards, in that Lis amphibia is all of the currently living things, whereas amphibia in general is all of the other ancestors as well. So if you want to refer to the ones that are still alive, the technical term is Lis amphibia.
Noted, understood, and I'll make sure that I use that in the future. Lis amphibia.
Yep, you just add LISS in front of amphibia.
Wonderful, thank you.
Okay.
So, as I'm looking at our notes here, do you have anything else to say on amphibians, or are we ready to move on to some land animals?
Not really. Just that, like you said, it's just way more messy than most people think it is. Like the big thing that I wanted to hit with amphibians was that we don't really use that system anymore. So good hosting, Mike. You led me into it.
I am glad, and maybe that can be our episode title for this episode. Science is a lot messier than you were originally thinking, or something along those lines. But I see next. Looks like we're talking about birds. Do I have to try and define what a bird is now?
I actually want to switch that. So let's do reptile first. So what is a reptile?
What is a reptile? So when I'm thinking about a reptile, I'm thinking about lizards. I'm thinking about things that kind of live in the desert, and so I'm thinking about them kind of being cold-blooded. And I know that like cold-blooded is probably either an outdated or problematic term, but something that doesn't really make its own heat. I'm thinking about something that can probably survive without there being a whole lot of water. I am in my head, I'm thinking of something that's kind of scaly and something that lays eggs. And so something that lays eggs is cold-blooded and can survive for long enough periods of time without needing to drink a whole lot of water. That's when I think of a reptile, that's what I'm thinking of.
Okay. So obviously, like I've said a couple times, there are exceptions to every rule, but that is generally what I think most lay people think of when they think of a reptile. So let's poke some holes in it, if I could. So there are quite a few species, actually many species of at least snakes that don't lay eggs, that they give live birth.
Really?
Yep. And also, for example, a lot of the extinct marine reptiles, things like mosasaurs that we've previously talked about, plesiosaurs that I think we've also previously talked about, the Loch Ness monster looking things. And then another the other like big group of extinct reptiles are called Ichthyosaurs, which literally means fish lizard. They're sort of like the most aquatically adapted, and also like the first like big marine reptile, because they actually, came out of the water to become reptiles and then went back to the water because they were like, hey, I want to be there now. All of those groups don't lay eggs because they're so adapted to living in the water that, like a whale, if they were ever to get on land, they would crush themselves under their own weight and wouldn't really be able to move. So they gave live birth in the water. There are some, when it comes to like being the cold-blooded, that is like you sort of alluded to might be the case. That is sort of a misnomer, in that the term that most people use nowadays is ectothermic, which means that they don't make their own heat. Because, for example, something like a bearded dragon, which is one of the most commonly kept pet lizards, needs like a basking temperature of like 120 degrees, which I wouldn't really call cold. So some of them do operate at really high temperatures, but they don't make their own heat, as opposed to things like mammals that are endothermic, so inside heat, which make their own heat. And there even are a couple reptiles that do that a little bit. There's a species of tegu from South America that the males during the mating season are partially endothermic. Not a lot, not to the degree that mammals are, but they raise their temperature a bit, which is really weird.
Do we know how they do that? Like, is there, like, is that kind of a mystery? Is that like, how does that happen that you can be sort of like, partially endothermic?
So basically, they do it the same way mammals do, essentially, is that when they respirate, which is the process of, taking oxygen that you breathe in, turning it into carbon dioxide, and using that combined with the food you eat to make energy. That's called respiration. In that process, mammals sort of altered that chemical, the sort of like chemical reaction that happens there, to give off heat. And in fact, only about 3% of what you eat is actually turned into food, or turned into like body mass, like muscle, fat, whatever. The other 97% is used to make heat. That's why mammals need to eat multiple times a day, whereas a snake, you can just give it a rat once a week for the bigger ones, maybe once a month, and that's enough food for them because they don't need to burn all of it to keep themselves warm.
That's nuts.
Yep.
97% of what I eat just goes into making me slightly colder than I feel comfortable I need to be while living in New York in the winter.
Give or take. That's a rough percentage. I'm sure it varies from species to species, but give or take around there. So reptiles are a really, really diverse group in that, and also they're a really problematic group, because if we think sort of in a, back in a paleontology sense, the first things that most people would consider reptiles were the early amniotes. That is another clade. And an amniote is basically something that has an egg with a shell around it, so that you can truly leave the water, so that you don't need to lay your eggs in water to keep them, moist, because they need that water to exchange oxygen and keep themselves going. Instead, amniotes, which is derived from the amnion. So if you ever heard of like amniotic fluid, if you've ever had to, like anybody who's ever had like a pregnant friend or relative had to get like a test done on the baby, they like sort of stick a needle in to the womb and they take some of the amniotic fluid. That's where that name comes from. And so it's basically just an egg with a shell around the outside to keep the water inside.
I am thinking right now, have you ever seen the video online by Bill Ward's History of the Entire World, I guess?
Yes, I have.
So I'm thinking of this is an early moment in there where you've got the animals that are actually leaving the water, and he's talking about basically this specific thing where animals were trying to figure out how on earth they were going to actually leave the water, and they figured out how to put the eggs inside of a shell, so everything was all self-contained. Am I thinking, is this the thing you're talking about here?
Yep, exactly. So that is the group Amniota. And here's where reptiles get a little problematic, because some people draw the line reptile there, We're saying if it lays an amniotic egg, an egg with a shell that keeps the water inside, that is a reptile. Which means, technically, mammals would be reptiles. So when you call Mark Zuckerberg a lizard person, you're kind of right.
When you say you are calling Mark Zuckerberg a lizard person, you were talking specifically about yourself here, because I want to make sure that that's coming from your mouth and not mine.
I plead the fifth.
When I think of Mark Zuckerberg, I usually think of, this was phrased to me in another podcast, a spider in a man costume was normally the best way I've heard Mark Zuckerberg described.
I also really enjoy that, although that would not be nearly as true as calling him a lizard person.
Understood and agreed.
So some people draw the line reptile there at amniotic egg because although, most mammals, there are 4 species of mammals currently alive that do still lay eggs. Spoilers. But the majority of them don't. But there is still all the same layers, that you would find in, a chicken egg or a snake egg. All those same layers are inside the womb of a pregnant woman or pregnant mammal. So we just sort of skipped the making an egg step and just sort of keep the baby inside the whole time. So technically, if you draw that line there, mammals are reptiles. However, people disagree on actually where to draw that line. So some people say it should be drawn at the split between the mammal lineage and what most people would consider the reptile lineage. And you can very neatly find where that split is because at the time there were 2 main groups, and the very early members of those groups have something very important different with their skulls. The reptile lineage have 2 holes behind their eye in their skull, and those holes allow muscle to go through and just give muscles an extra place to attach, jaw muscles specifically, so it gives them more, variation in where they get their jaw pressure from. The other lineage has only 1 behind their eye socket for that muscle attachment. So that's the big difference. So reptiles, as most people know them, are the 2-holed lineage called diapsids, and mammals are the 1-holed lineage called synapsids. Di meaning 2, and syn, I'm sure that's probably Greek. I don't think it's Latin, but I think that's Greek for 1. I think it's the same root as like single. So that is where some people draw that line, where if it's got 2 holes in its skull, it is a reptile. That is sort of personally where I would draw that line if I had to, but fortunately that's not my job.
It seems like this is kind of one of those things that goes back to what we were talking about earlier, where people disagree on where to draw lines on how to classify things, and just the whole classification system is a lot messier than people would tend to believe, because not everyone, very smart people, don't exactly agree on where to draw the lines on any particular classification of a species or of a group of species.
Exactly. And it's if people don't agree on where to draw that line, that group is kind of useless, which is why people don't use reptilia anymore. If you look in the last probably 20 years, you will be very hard pressed to find a good scientific article referencing the name reptilia, or the class reptilia, in like a real sense, other than just having to mention it because they have to, because it is technically a member of that, whatever that means. The only exception to that, I would say, is people publishing a paper trying to sort out where this line should be drawn. But somebody, say, discovering something new, they might call it a reptile, but they do not use the class reptilia, which is kind of seems, like a little bit of an oxymoron.
It sounds as though they're kind of using the colloquial term reptile instead of any kind of scientific classification.
Exactly. And so there's 2 main groups of reptiles that are around today. There have been many, 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 many more in the past. So things like those Ichthyosaurs and Plesiosaurs do not fit neatly into either one of these 2 groups I'm about to mention. Plesiosaurs are one that is iffy whether it does or doesn't. We're still kind of not sure. Ichthyosaurs, we know for sure do not fit in either of these two groups. And turtles are also another one where we're like, we genuinely do not know what, like, where turtles came from.
That's kind of amazing. Something as ubiquitous as turtles are today, just the number of questions that might be around that. I just find that kind of thing both funny and kind of heartening that there's still a lot of good work to still be done.
Absolutely. So there is another group that is not used anymore called anapsids, which means no hole. So that is the term that was used for before the diapsid and synapsids were around. So before they had either two or one, they had no holes. And if you look at turtle skull, they don't appear to have any holes where they should be. So at first people were like, oh, they're anapsids. They're super, super primitive relative to the diapsids. We've sort of come to realize that that's not true, in that they do have the two holes. So they are diapsids, but they just sort of lost the backside of the hole. So they just sort of were like, hey, I don't need the back of my skull anymore. They are diapsids. In that sense, they are, in my opinion, reptiles. I don't think anybody would look at a turtle and be like, that's not a reptile.
Couldn't you look at it and say it was an amphibian?
Technically, yes. Just like you and me are.
Yeah. Oh, you know what? I hate the fact that you're right.
So they are not amphibians because they do lay a true shelled egg. They have to come on land to do it, which I think is pretty solid evidence of that. They don't lay their eggs in the water. So,
Oh, okay.
but
Okay.
so the two main groups that I was mentioning earlier are the archosaurs, which means ruling reptiles, which is a little, self-servy, but whatever. And then there's the lepidosaurs, which are the scaled reptiles. Technically, all of them are pretty scaled, but that's just what it technically translates to. So, lepidosaurs are snakes, lizards, and this weird thing called the tuatara, which is, it looks a lot like a lizard, but it's technically not in the same group that lizards are. Those are the only ones that we have today. That is the group that most people think, okay, if the plesiosaurs, the Loch Ness monster looking guys, if they are true reptiles in this sense, then they probably fit in that group. And then the archosaurs are represented, in modern animals today by crocodilians and birds.
Does that lead us into our next category?
It sure does. So the closest living relative to birds are crocodilians. Fun fact. So with that, Mike, what is a bird?
You know, I've actually looked at this question a couple of times now. What is a bird? And I think my first thought, along with, most normal people, was like flight was kind of one of the main characteristics
Mm-hmm.
until I remembered the penguin. And then I realized, okay, either flight is not an essential characteristic of birds or penguins aren't birds. And I think it'd have to be the first one, that flight is not an essential characteristic of birds. But if flight is not an essential characteristic of birds, then for the life of me, maybe it's like the beaks or something, for the life of me, could not put birds into a category that also includes penguins.
Okay. So I'm going to blow your mind here for a second. That is absolutely a very reasonable conclusion to come to. 100%. That flight is not a prerequisite for being a bird.
Okay.
However, it is, but penguins used to be able to fly but can't anymore.
Oh boy.
Penguin ancestors used to be able to fly, as is true with ostrich ancestors, emu ancestors. They just no longer can. They gave up flying to be able to do something else.
So if I can try and get this right, and you're gonna have to remind me of the term here when we're talking about branches of the tree of life, where we're taking everything one specific branch. What was that term?
That is a monophyletic group or a clade. You can use either.
All right, so I'm going to use clade because it's one syllable.
Yep.
So we take the clade of all kind of flighted species, flighted animals. That happens to include what we today look at as penguins that no longer have that characteristic of flight, but their ancestors did, and they're able to go back to kind of that one split. So just because penguins don't happen to fly today, they still belong in the category of birds because their ancestors were able to fly. They come from that same branch of the tree of life. Is that right?
That is the whole message that I wanted to drive home for this entire episode. So, good job, Mike.
That's what I'm here for.
So, yes. So, flightlessness is really hard to sort of characterize. Last time that I saw somebody attempt to figure out how many times flightlessness evolved, because it's not like penguins and ostriches are that closely related, even though they are both flightless. The last time I saw somebody try to figure out how many times flightlessness evolved, it was somewhere in like the 17 range. But they were like, it's probably closer to like mid 30s because it happens a lot on islands.
When you say 17s or mid 30s, what are you talking about there? 17s, mid 30s?
The number of lineages that gave up flying.
Gotcha.
So it happens a lot on islands because, especially if, birds are very famous in their island evolution, because they can fly to an island and then, or get blown in like a big storm to an island. And then if there's a good number of them that got blown there over, the course of a good number of years, they can start reproducing. But it might be, too far away to, for a storm to have blown something like a cat, something a ground-based predator. So, a couple members of this group become more ground adapted, of these birds become more ground adapted, and then they just eventually lose their ability to fly. But islands tend to have a generally pretty poor fossil record just because there's not a lot of land area to them, and they're generally eroding instead of depositing sediment, which, as we've talked about, places where you erode is not a great place to preserve fossils. So based on, projections, it could be as many as like mid 30s for the number of times that flightlessness has independently evolved in birds. But the first birds were flighted. They could fly. So that is a defining characteristic of the class Aves, which is the scientific name for birds.
So things that at one point, if I could try and put a definition on this based on what you've talked about, would a definition be something to the effect of a category of birds that either now, or pardon me, a category of animals that now or at one point in their evolutionary history had the ability to fly?
Yes, but you need to add a couple things to that.
Let's do it.
So the simplest way to describe a bird would be a flying reptile with feathers. That is the simplest way. That technically could apply to some dinosaurs that are not birds, but the feathers are really important because otherwise they're kind of hard to distinguish from pterosaurs, which, as we talked about in episode 2, I believe, about dinosaurs, that pterosaurs are not dinosaurs. They are their closest relative, but they are not dinosaurs proper, whereas birds are dinosaurs proper. And feathers, true feathers, only have evolved in dinosaurs and, therefore birds.
Okay, so there's kind of more there than just that, but I can kind of see the general point here when it comes to birds. Is there anything else that we should be aware of when it comes to birds? Is there anything else that when I'm trying to think of birds, is there anything else that kind of makes that more complicated, or is that the general point when it comes to what birds are?
Birds are the big reason why reptilia doesn't work, because when people think of reptiles, they don't think of birds. Because
Correct.
to most people, birds are not reptiles, even though they are as much of a reptile as a crocodile or a lizard. They are just as much of a reptile as those other animals because they're in that same group. Wherever you draw that line, if you exclude birds, you are making a paraphyletic group, that group that, includes everything except, this one branch that doesn't happen to fit the definition that I'm using. And those are bad. We don't like those. So if you want to make a clade of reptiles, you need to include birds. And so that's the big reason why reptilia kind of falls apart and why a lot of people don't use it. But if you preface up front that you are including birds in the statement or you are excluding birds when you say reptile. I've seen that, where in the introduction, in the first paragraph or two, it'll say, when we use this term, we are meaning this and excluding these members of this group, although we acknowledge that they are in this group. I've seen that. That's very common with dinosaur papers because they're talking about, a group of dinosaurs, but they don't want to talk about birds. So they're saying, herein we are talking about dinosaurs. When we say dinosaur, we are meaning non-avian dinosaurs. So we are not talking about birds.
So basically, the term reptile, as well as dinosaur, and I assume lots of other things, needs to be kind of defined way more specifically than either is colloquially used or even is agreed upon in members of science. And so, as long as you are defining your terms specifically and properly in whatever it is you are doing, you can still use these terms. But if you were just kind of using them on their own terms, they're sort of meaningless once you actually get down to it.
I wouldn't say meaningless, but steered away from is probably the sort of phrase that I would use.
Less helpful than you might think.
Right.
Perfect. Okay, so I think we can move on from bird, and we can kind of quickly here hit the last one we have here, which is the one I'm probably most familiar with. It looks like I'm going to be asked to define what is a mammal.
Yes.
So when it comes to mammals, I'm trying to think about. I think I saw something on Facebook earlier this week where it was like coconuts are mammals because they have fur and produce milk. So, well, I'm not going to quite make that claim. I think that there's something there that might kind of make sense. You were talking about how birds need to have feathers. I'm thinking mammals probably need to produce some sort of hair or fur. They probably need to produce milk of some sort, which I assume would be some sort of a defining characteristic of mammals. And they probably generally give live birth. And I know that's kind of one of those things whenever you say that, somebody is immediately going to start yelling up and down about a
Yep.
platypus.
Yep.
But I feel like I still want to mention that because that seems like it's one of those defining characteristics that you just need to include a but at the end of. So fur, milk, live birth is kind of what I'm going for when it comes to mammals.
Pretty much. It depends sort of how you define fur, because technically fur and feathers are pretty similar, especially for what they were initially evolved for. So dinosaurs originally sort of developed fur. And again, I always have to say, like, dinosaurs didn't, sort of think, some feathers would be good right now. It was just some modified scales that happened to be bigger and have some more surface area to keep in heat, which, as we talked about in the dinosaur episode, is why some people think that dinosaurs probably were endothermic, producing their own heat, because otherwise, why would you need feathers to keep in heat if you weren't making your own?
Evolution doesn't have a thought process, evolution just is.
Yes. So that is, primitive feathers are not at all like bird feathers that we see today, sort of with the big, sort of like fan shape. They're very much like hair. They're sort of very thin, kind of filamentous. They might be a little more fluffy per individual sort of like shaft than most people think hair is, but they're not all that different. The big thing is milk. Only mammals produce milk. That is one of the few things where I'm very confident in saying that, like, no other group has ever done that. And even things like platypus and the other so there's one species of platypus, and like I said, there are 4 species of mammals that lay eggs. The other 3 species are echidnas. There are 3 different species of echidnas. They are also, those 4 species make up a group called monotremes, which are just the egg-laying mammals. Even they produce milk. So every mammal that we are aware of produces milk. And then like you said, we already kind of addressed the live birth. Although I do want to talk about marsupials for a minute when it comes to live birth, just because marsupials are really cool and weird.
I think I know what a marsupial is, but once again, if you could just tell everybody what, very quickly, when you say marsupial, what it is that you're talking about.
Marsupials are mammals that have a pouch for their little baby. They don't lay eggs, but they give birth to a very, very undeveloped baby that sort of just crawls its way into the pouch, where it basically just finishes developing. So they just give super, super early birth, and then their pouch serves as the womb for the rest of the baby's development.
I'm thinking kangaroo here.
Kangaroo, wombats, mostly Australia, also a lot in South America. And everyone loves our friendly neighborhood single North American species of marsupial, which is the opossum. I love those little guys.
Absolutely. Who wouldn't?
But yeah, there are lots and lots of them in Australia, also South America. But the main diversity in mammals is the placental mammals, the ones that you think of where, the mom gets pregnant and there is a placenta that attaches to the baby. That's where the baby gets its nutrients. Technically, marsupials do have a placenta while the baby is still like in the actual womb, but it's there for maybe like a week and then it crawls up into the pouch. So marsupials are just also super weird in that a little bit of adult scientific language, but this is a science podcast, so I'm going to mention some anatomical terms. Try not to giggle. So marsupials
I'm just
have,
going to mute myself instead of trying not to giggle.
sure, marsupials have two penises. Mike, you said you were going to mute yourself.
You didn't give me enough time.
Okay, they have two penises, and correspondingly, the females have two vaginas. And some species of marsupial have a third vagina that is exclusively used for birth and that comes and goes. It is not always there, which blew my mind. I had no idea that was a thing until I listened to it on another science podcast. In that they also have a cloaca, which is a term most people think of with birds and reptiles, in that it is a single orifice that is used for both excretion of waste, pooping, peeing, and also reproduction. Obviously, you are a placental mammal. You do not have those. Or you do not have a cloaca. You have separated tubes for those things. And that just blew my mind that marsupials had a cloaca. And I wanted to share that with you. So, yeah. You can come back now, Mike. It's okay.
I am now off of mute. I got a good chuckle to myself on that. But I do love the fact that there is all of this variation in all of these things that I would have thought were so simple until it was kind of, it was kind of my job to start thinking about what these things might be, whether it is, what is a mammal and all of the different variations of that, including the multiple organs that some of these mammals might have, such as marsupials.
Absolutely.
And with all of these, just the fact that it's all a little bit more complicated than I would have originally thought, and that is a feature, not a bug, I think is just it's sort of a beautiful part of the kind of science that we're talking about here.
So I really love that too. But let's see, what else about mammals? So mammals are probably the most cut and dry clade of vertebrates, in that there's really not any members like alive today of any other group where you're like, I don't know where that belongs. Unlike birds where it's like, are birds separate than reptiles or aren't they? At least in like a layperson's mind. Um, you know, in science, they are not. Birds are reptiles. But there's nobody really arguing that like you or I are what the layperson thinks of as a reptile. Where it gets a little fuzzier is where to draw the line between mammals and their ancestors. Because if you remember earlier, I didn't say that I drew the mammal line at that split between diapsids and synapsids. There are plenty of non-mammal synapsids. Things like Dimetrodon, for example, commonly mistaken for a dinosaur. That is sort of the long lizard-looking thing with the big sail on its back. That is called Dimetrodon. That is not a dinosaur. That is more closely related to us than it is to dinosaurs. And depending on where you draw that mammal line, I don't think people really consider Dimetrodon and like its close relatives mammals, but people sort of argue about where do we draw the line for what is a true mammal and what is the group that mammals evolved from, which is called therapsids. people sort of argue about where to draw that line because, like I said, milk is sort of like the main thing for mammals. But milk is produced by glands, and glands don't really fossilize. So we don't know which was the first thing to produce milk. We have no idea.
So it's less about arguing what species might fit within a particular definition than it is saying we have a definition that seems to work reasonably well. We just don't have all of the information to place, every known species either in or outside of that definition. Is that about right?
Yeah. Yep, that seems pretty good.
Wonderful. Is there anything else that we need to know about mammals? Is there anything else that we need to know about kind of all of these vertebrates in general?
I just really like that, you might see, if you happen to be members of some science groups on Facebook, I'm personally a very big fan of a group called Wild Green Memes for Ecological Fiends on
I
Facebook.
believe I've seen you share some of these memes before.
I love them. They're excellent. But so you may occasionally come across a meme about like something that is clearly not a fish being a fish. Technically, all tetrapods are fish. I just really enjoy that. So, and I thought it was very funny. Back at the beginning, when you gave your definition for fish, you mentioned dolphins and whales. And I bet a lot of people were like listeners might have been like, oh, those aren't fish. Those are mammals. I'm like, psych, they're both.
Awesome. Let's make it more complicated right at the very end of the podcast.
Because, like I said, you never stop being. And I think I elaborated on this a little bit in probably the dinosaur episode 2, and then also the first episode, where it's like you don't stop being what your ancestors were. There does come a point where it is no longer useful to call you that thing. Like, it is not useful when referring to, say, whale anatomy. Or let's use something that's not even in the water. Referring to sloth anatomy to call it a fish or an Osteoichthyon, even though it technically is, it's just not useful. So there does come a point where that happens, but that doesn't mean that they're no longer a part of that group. And I'll use the same analogy that I used in that episode, where it's like, even though my mom's maiden name is different from my last name, that doesn't mean that I'm not a member of that part of my family. That doesn't mean that I'm not in the same lineage as my grandparents. We form a monophyletic clade ourselves. Just because something's called something different doesn't mean that it has shed all of the characteristics. Because even in mammals, you can still see, if you know what you're looking for, some of the old characteristics. For example, there is a nerve that goes to, I think, in your tongue. And you would think, oh, it goes from, it's like, I think it's the muscle that controls your tongue, actually. But it's called the vagus nerve. I don't know exactly what it does, but I know that's the name. But it goes from your brain, goes all the way down to your heart and wraps around your aorta, and then comes back up to your mouth. Doesn't seem like that long of a journey until you get something like a giraffe, where that nerve goes all the way down its neck, wraps around its heart, and then comes back up to its mouth.
That seems inefficient.
It's very inefficient, but the reason why it's like that is because fish, most of their internal organs, especially like their heart, is very close to their head. So at the time, that probably was, one of the most efficient paths to take. But you can't, with a very important nerve like that, you can't just sort of bypass that step of going around the heart. That's just how it knows how to grow. So things like that, where there's still remnants, if you know the things you're looking for, of humans still being fish. Another good one is part of your vertebra, which is called the centrum, which is sort of the big round part, not sort of like the arches that come off it or anything. That is a modified version of that stiff cartilage tube that I mentioned way back at the beginning of what is a vertebrate. That's called the notochord, and that has since become part of our vertebrae, even though it's no longer made out of cartilage. So you can still see it. You just got to know what you're looking for.
Just got to know what you're looking for, and that is why we have you around to tell us what it is we should be looking for when it comes to to all of these. And so when it comes to all of these kind of, we were talking specifically about species of vertebrates here. And while it applies very well to that, it applies pretty well to kind of everything it is that we're kind of be talking about on this podcast. Things are a lot more complicated than you probably remember. Things are a lot more complicated than you probably think. Even if you are kind of a pro science or a science minded person, it can be a little bit more difficult to try and place things in categories. And that is the point. That is a good thing. That is a reason to appreciate the process, not a reason to necessarily get frustrated by what it entails, even if it can be frustrating to be relearning the kind of science that you thought you already knew. And that was kind of one of the main points of this episode was unlearning science with, you know, looking at different species of animals and species of vertebrates that go along with that.
Yeah, I really like the way you phrased that. That was really good.
Wonderful. Well, I think that we can go ahead and wrap it up here for our first episode of 2021. My name is Mike. That is Gavin. Science can be a little bit messy sometimes, but that is okay. Gavin, I hope you have a great start to your year, and I will see you next week. Take care, buddy.
Absolutely, and all of our listeners, I hope you have a wonderful start to your year. I hope you actually use that gym membership, um, or
Not
or
yet.
or or get something analogous while you are still at home. Uh, anyway, have a great year, everybody. See you next week.